We are good to go. Please go ahead.
Thank you, Bishop. Thank you very much, and good morning, everyone. First of all, I would like to wish everybody a happy Valentine's Day. Just know that you are loved by your family and close friends, and you are valued by your colleagues. Today, I'm here to present to you a series of case studies uh, to support the topic of operational savings using calcium sulfonate grease. There we go. And thank you, Bashad, for the summary of, or my bio. I just kept this slide in the presentation to share my contact information. My office number is 832-486-1519, and my email is pretty straightforward, fhayes@citgo.com. As Bashad said, I'm currently a product specialist with CITGO Lubricants. My product responsibilities are development and maintenance of our functional products, aka specialty lubricants, aka everything other than the hydraulics and compressor fluids and engine oils and grease. As you see, I have a variety of experience in and out of the lubricant industry, but I do have over 25 years experience in machinery lubrication. So I just want to share some of my experiences with you. In this present, I've worked with CITGO for only about 10 or 11 months. So in this presentation, I'm sharing experiences from my over 25 years of lubricant experience. Today, I wanted to, before we get into the case studies, I wanted to share, uh, wanted to kind of build up to the case studies themselves and to share the importance of being able to survive in a wet environment, high load operation, and high temperature environments. So if there's a variety of experiences here, I could just share briefly the factors that affect grease bearing life, and then we'll review the differences, the key differences between conventional greases and calcium sulfonate greases. And then we'll review the case studies, three of them, one for wet applications and the food application, one for high load uh, operation in a wood pellet mill, another for a high heat environment at a corrugator plant. And before I forget, I want to thank all of our international guests here for joining in. I'm glad that the STLE Toronto section has reached out uh, beyond your region. Okay, so here we go. Let's talk about factors that affect grease bearing life. Bearing failures not associated with normal fatigue are what I want to classify as premature. Possible causes are excessive load, accelerating this fatigue of the bearings, faulty mounting of the bearing causing vibration, accelerating wear and fatigue. Bearing components, maybe the wrong metallurgy or the wrong quality of manufacturing may be involved. Improper speeds. If the bearing is run too slow or too high of a load or too fast, generating too much heat, uh, maybe the speeds not match with the base oil viscosity of the grease or the lubricant. Contamination that may cause corrosion or excessive erosion or wear, abrasion. And then also, there's a phenomenon called high temperature corrosion. I just want to throw that in so you could go Google it and look it up. It's a real phenomenon. It's really occurs at about or above 300, above 400 Celsius, 750 Fahrenheit. And so these are, just possible causes. These are more on this page. There's more causes that we can't really control with a lubricant, and those are more operational causes. Here's more lubricant application causes for bearing failures that will cause premature wear. Improper lubrication. Okay, that sums it up. Well, what is improper lubrication? You use too much lubricant. If you add too much lubricant, you generate heat. Heat of the lubricant degrades the lubricant and can create acids and degrades bearing. Not enough lubricant guess what? Heat is generated from under lubrication, but the heat is generated from actual metal-to-metal contact, uh, generating more wear. We could use the wrong type of lubricant. Well, wrong type of lubricant could address grease incompatibility issues where you have one you have a lithium complex grease in service and you want to move to a calcium sulfonate grease. They may or may not be compatible. You know, most obvious incompatibility is when you're mixing a clay-based grease with any other grease. Uh, when greases are incompatible, they'll usually soften and run out of surface. Sometimes they'll harden and cake up in the bearing. Another another example of wrong type of lubricant is just using the wrong type of lubricant for the wrong grease for the application. And this is one reason why I'm speaking to calcium, operational savings by using calcium sulfonate greases. There's nothing wrong with a lithium complex grease, but here we're speaking about how we can gain value with calcium sulfonate greases. And another improper lubrication incident is using the improper base oil viscosity. And as we all know, and I'll cover a slide on how a grease is made, but if the base oil viscosity is not appropriate for the application, that will just generate more wear. Because as you know, in conventional greases, it's the viscosity, it's the base oil that does the work, keeps the bearing surfaces separated. So then you go back to, is your viscosity too high or too low in for for the application? So those are the factors that affect grease bearing life. The first page covered factors that we don't have much control over. The second page covered factors that we do have control over by ensuring that we make the proper lubricant recommendation. So you might want to ask, okay, so what's the difference between conventional grease and calcium sulfonate grease? If you already know, please bear with me. So grease contains three primary components. It's the lubricating fluid, the base oil, the additives, and the thickener. These numbers may vary, so 70 to 90% base oil, just a trace of additives, 5%, just like in many lubricants, just a little bit of additives, and then thickeners 2 to 25%, just depends on what NLGI grade you want to meet. Well, how do you make a grease? Just basically, and uh, I just want to describe the saponification process. Just basically, you add an acid plus a base, and you end up with a soap. Oh, look, there's water as a byproduct, then we dehydrate the grease. The common acids that we use are stearic acid, 12-hydroxystearic acid, tallow-acetic acid, sebacic acid. Common bases, lithium hydroxide, calcium hydroxide, sodium hydroxide, barium hydroxide. We're talking about conventional greases here. And they say may have heard just a lithium grease. So what kind of lithium grease is it? Is it a lithium 12-hydroxystearic grease, or is it a lithium stearate grease? So it just depends on end result and the resources available. End result for grease performance, thickener performance, and the materials available on the selections between the acids and the bases that are used to make the soap. Okay. And so thickener types, just what are the conventional grease thickener types? You have the simple soaps, are the lithiums, calciums, sodiums, and bariums. You can complex these thickeners to make them stronger in service. You can complex a lithium, calcium, aluminum complex, and barium. I really haven't heard of just a simple aluminum thickener. It's usually aluminum complex. And then your non-soap thickeners, the polyureas that are in short supply now, calcium sulfonate greases, which are still on the pricey side, but it may become our favorite just due to supply and demand of lithium. Then our clay greases that we'll run into every once in a while that are really good for high temperature surface, and the fumed silica, which I've seen used for a variety of applications. I love showing these pictures of magnified views, like 50,000 times magnification of the different thickeners. You can see how, when I said when you complex a thickener, the granular structure of the thickener gets stronger. So you have a lithium with smaller fibers and lithium complex with thicker media fibers that they hold on to the complex greases, hold on to the base oil a lot easier. Aluminum complex grease, I gotta be straight up. I've never been a fan of aluminum complex greases. We all make them, use them for possible wet applications or food grade applications, um, but they don't tend to hold on to base oils as well as the lithium complex or the or the calcium sulfonates. And the barium complex is the strongest thickener and the strongest fibers. The greases that that sorry hold up to shear. The thickeners that hold up to shear the best. So we spoke to different types of thickener. So there's additives also. Just the 5% of additives. They just enhance. And additives function similar in greases as they do in just liquid lubricants. Fluid lubricants, they enhance and add to the functionality of a base oil and or the thickener, in this case for grease. Um, you have to choose the right additives to make the grease effective in the service that it's designed for. Common additives or anywhere additives, and these could be anywhere from the traditional sulfur, phosphorus, EP additives to solid lubricants in that are added to greases. Well, you got your extreme pressure sulfur phosphorus. You got tackifiers, polymers. These are used quite a bit in greases, and pretty much almost every grease, except for maybe a very fluid straight lithium grease. Solid lubricants, the mollies, typically, or graphites are usually friction modifiers, but sometimes represented as solid lubricants. And in our calcium sulfonate greases, we have calcium carbonates, or the natural form is calcite particles. Those are all solid lubricants. And there's others. Corrosion inhibitors, antioxidants, friction modifiers, graphite, and dyes. And we'll never get away from our farmers wanting a red grease. So grease functionality, and we're still talking about this. We're talking about conventional greases. So I'm about to transition over to how calcium sulfonate grease works. So for conventional grease, so a definition: a solid to semi-solid material produced by the dispersion of a thickening agent in a lubricant. Okay. Um, what that means is the thing, I probably wrote it down here. Okay, so liquid is trapped in the thickener, which has a three-dimensional structure with voids, kind of shown in the picture here. So just think of a sponge. Grease acts like a sponge. We all know this. So the base oil itself is what does the work in the conventional grease. So the thickener carries the base oil to service. Base oil does its work, and the thickener recovers the base oil in the other side of the load zone of the bearing. That is the ideal way that a conventional grease works. Of course, there's a little bit of travel of thickener in the load zone also, but it's primarily base oil. So it's a wicking effect that we have, that we promote by producing our conventional greases. So it's the nature and properties of the thickener and the characteristics of the liquid lubricant together determine the basic properties of the grease. Typically the adhesiveness, the wear protectants, the NOGI grade of the grease. So let's transition to calcium sulfonate greases. I like to call them special. And this, as I showed you, magnified views of the conventional thickeners. This is a magnified view of calcium sulfonate grease over to the right. It's an amorphous calcium sulfonate. Here's a magnified view of it. It's a pretty good surfactant effect there. But once we crystallize, or you could say complex, a calcium sulfonate grease, you have a crystalline calcium sulfonate structure. And what I get out of this picture is that the calcium sulfonate thickener holds onto the oil, to the base oil, very well. and everything else every other liquid that's introduced to it. So why do I call calcium sulfonate greases special? The functionality of them is they're excellent multi-purpose greases. It's debatable whether they're good low temperature greases, but I've seen some greases formulated for very good low temperature applications that include calcium sulfonate thickeners. The functionality is inverse of most other greases. Now listen to me and kind of open your mind about what I'm saying here. The thickener does most of the work. The thickener travels through the bearing load zone. This is like the thickener and everything in the thickener, the base oil, the thickener, the entire content of the grease, if the calcium sulfonate grease is manufactured well, travels through the load zone. That's the base oil, and this is my wording, the base oil allows the thickener to move. That's the primary that's the primary effect of the base oil, allows the thickener to move. Because and I'll go with the inherent properties of the base oil further down this page, but it's ideally a permanent emulsification of the oil in water. So as I said, in conventional greases, the base oil does the work. With calcium sulfonate greases, is mostly the thickener does the work. You can slow down the thinning effect due to high temperature with different base oils in a calcium sulfonate grease, yes. But most of it works from the thickener. So performance-wise, you get a higher dropping point because the thickener with a calcium sulfonate grease, because the thickener holds on to the base oil. You get a strong, high temperature, long life properties because of the stability of the thickener. Inherent wear protection in the thickener. I mentioned earlier calcite particles, calcium carbonate. You get inherent corrosion protection from the thickener. It's polar. It's polar. It sticks in metal. It's a modified detergent. Inherent adhesion from the thickener because of the polar nature of the thickener. And don't want to mislead you. There's polymers in every calcium sulfonate grease or tachyphers in most calcium sulfonate greases that I know of, but inherently very good adhesion. Oxidation stability is really great because of the thickener. Now, if you want the best oxidation stability, you still have to add oxidation inhibitors to the base oil. And so as I said before, calcium is debatable on whether you can make a calcium sulfonate grease suitable for low temperatures. I say yes, you can. So if you have low temperature applications, you just have to make sure your calcium sulfonate grease is formulated for low temperature pumpability. And so how does this structure work? Well, excuse me, how does the calcium sulfonate thickener work again? I guess what is the chemistry behind it? Well, it's a surfactant. It's pretty much a fancy micelle structure. So what I'm showing now is just a basic micelles that are in surfactants to help clean and disperse oils and waters. You have your polar heads here, and your oil soluble tails that trap oil and trap water also. That's how dispersant and surfactant may work for you. Well, a similar structure when we speak to over-base calcium sulfonate. This is before it's complex to make a strong calcium sulfonate grease. The micelles are included in the micelles are the calcium carbonate particles. This is where you get your wear protection from, the calcite particles here. And you have the oil still trapped by the oil soluble tails here. Well, in the converting process, once we include a promoter solvent, here's the structure, the grid structure that complexes the grease and makes it a usable thickener. And these calcite particles, calcium carbonates are still involved. That's where you get your natural EP protection from right here, the calcium carbonate. This grid structure, allows for the thickening of the over-base calcium sulfonate. Lithium greases are still the most sold greases uh, globally per volume. Lithium complexes is next. But when it comes to uh, maintenance managers and operators and engineers um, at manufacturing facilities, they want to know what is the best grease for my operation. What grease is going to last the longest? Is going to help my equipment last the longest. What is and um, these are your two candidates: calcium sulfonate complex and lithium complex. Well, and polyurea is not a bad grease also, but I'm here to show you how I was able to save um, our customers money uh, by using calcium sulfonate grease, typically over lithium complex grease, where you have a higher driving points, like I mentioned. Maximum operating temperatures are typically higher. These are synonymous in terms here. They're both good for quote high temperature use, but that's a discretionary term. Like what is high temperature? Because they'll both fail at extreme temperatures over 500 degrees Fahrenheit for sure, even 400 degrees Fahrenheit. Low temperature mobility, again, we talked about that a couple of times already. I just stay with the industry tagging of calcium sulfonate is fair for low temperature mobility, but you can definitely formulate calcium sulfonate grease for good low temperature mobility. Mechanical stability is definitely better for mechanicals for calcium sulfonate. It's still good for lithium complex. So the industry calls them both excellent. Um, Water resistance, both excellent. Calcium sulfonate, they'll both absorb water, but as far as staying stable in water, calcium sulfonate grease stays stable in water. Matter of fact, I've had a novice friend of mine uh, rub calcium sulfonate grease um, emulsified with water, and one without water emulsified, and asked which one's a better grease. And she chose the emulsification uh, of calcium sulfonate in water. So functions well in water, still get wear protection, still stays in place, still get good corrosion protection in the presence of water. Unlike lithium complexes and aluminum complexes, you really have to fortify aluminum complex and lithium complex to perform as well as the natural protection against corrosion of a calcium sulfonate complex grease. Oxidation stability is excellent due to the nature of the thickener, and then you can add to it actually. Um, Texture, both smooth. Um, they can both be dyed whatever color you want. So those are kind of comparison of the characteristics between calcium sulfonate and lithium complex. So with these case studies, I was able to demonstrate the benefit of calcium sulfonate grease service in the wet applications, high loading, high heat environments. So I hope that was a good introduction to the case studies, so now you can understand the different properties of a calcium sulfonate grease and how and why they're going to help in these three case studies. First one is the wet application. Here's the customer information. It's a chicken processing and packaging plant. Uh, and usually in food manufacturing plants, there are different areas in the plants for different stages of processing the food. This one is called the cooked product area, where they sort and package cooked product. There's 30 rolling element bearings involved in this area, and this operator maintenance crew very resistant to changing grease. They were using a silica-based grease, and that was part of the problem. At this location, here's the problem. They conveyor wash down. They wash down the conveyors every night with hot water based cleaning solution. Well, they have a conveyor pillar box, 4 bolt bearings, just like every manufacturing plant. But these bearings, they fail every 6 months due to corrosion. That's a very high rate of bearing failures for a manufacturing plant. They're using a clear silica gel grease to conceal occasional food contamination. Boy, that raised red flag to me, but there's not much I can do about it. But explain that, hey, look, and they probably know it. That's why they're concealing food contamination by the grease, because there's no more than, according to NSF, cannot have more than 10 ppm of grease contacting your food. And so they're definitely contacting food with the clear grease quite a bit, just so they can maintain the production rate, or and still use the the grease. I mean, that was just their best solution at the time. Well, here's a solution I had for them. Uh, let's use a calcium sulfonate complex grease. It's not clear, but you use greasing rates where you don't spill over grease onto your product. It's an NSFH1 grease. The color can be white or off-white. Um, daily purge. Um, it would, because of the washing process, it's still a good idea to daily purge with a fresh grease, just like you're doing with your clear silica gel grease. Um, and but your bearings will last longer with our grease. They decide to change corroded bearings when they're near failure, so they implement the use of the calcium sulfonate grease, and then they would just change the bearings on the they implement use of calcium sulfonate grease on the existing bearings, whether they're fresh bearings or heavily corroded bearings. And then whenever the bearing fails in their failure, then they'll change the bearing. That was their approach. So they monitored their bearings for a year. And once the bearing, there's no new corrosion on the new bearings, so, or even on the old bearings. So we stopped the rate of corrosion. And once they purged through all their bearings, they were using fresh bearings that lasted a heck of a lot longer. So ran a cost savings calculation, say if 30 bearings in this cooked area, then in the previous bearing failure rate is 6 months, then they projected component life. And this is just a conservative estimate for them, saying I only monitor them for a year. It's just, say if your bearings just doubled their life of what you've been experiencing. Say if each bearing costs $50 for the material, and for 4 man-hours per bearing and $75 labor costs, saves them $10,500 in annual maintenance and savings. So here's the operational savings that the maintenance crew can brag about in their plants for this chicken processing plant cooked area. So that was a case study, a wet application case study. And again, the reason why calcium sulfonate grease was able to slow down corrosion is because of the polar nature of the thickener in the calcium sulfonate grease. Let's look at our high load operation in a wood pellet mill, where we're able to save the customer quite a bit of money. In this case, because the customer is using a series of 12, they're using 12 CPM 7900 presses in a wood pellet mill in East Texas. The site consumes about 160,000 pounds of grease annually. It's a really good grease account to have. There are two double helical bearings in each CPM roll, each California pellet mill roll, California pellet mill outside shells. And then here's what the bearings look like when you pull this front cover off. The bearings are right in here that make the pellets. Grease is injected right down the middle of the shaft. The roll bearings are right in here, and then the roll shell is right here, and then there's the outer liner, which the shell pushes the wood through the liner. Probably not using the right term, and makes your pellets. So there's two double helical bearings in each CPM roll. So it's two bearings, two double helical bearing in each roll. Costs about $2,200 to replace just one roll. That means that's the cost of refurbishing and setting it back in place. CPM itself, and I'll also go over in the Androids, their major competitors, lubricant recommendations, but CPM recommends an NOGI-1 lithium complex synthetic grease with an ISO 460 base oil. Well, okay, let's talk about I know this is a high load application, but it's also pretty well sustained elevated temperatures. but in this case, load is more of a factor in bearing life than temperatures. But temperature is a factor. Temperature, load, and moisture content of the wood are also factors. So roller bearing temperatures in the wood pellet mills, they typically run between 250 and 300 degrees Fahrenheit. Well, for international audience, that's 120 to 150 degrees Celsius. Depending on ambient, it depends on ambient temperature, wood type, machine design. Just depends on many different factors that affect pellet mill temperatures. But there's loads also. These temperatures should be kept below 325 Fahrenheit to protect the metallurgy of the bearings and the roll shells. Okay. Here's a kind of schematic of the bearing. I was kind of showing you from the picture. The grease is injected right in the middle of the shaft and flows to the double helical bearings. This one double helical bearing, here's another double helical bearing, and here's a cross section of the roll shell. And the roll shell has many different designs, and which also affect the shell life and the bearing life uh, of the rolls. So here's the case. The problem is that their bearings, roll bearings with lithium complex greases, roll bearings with the grease that was recommended by CPM, only lasted 300 to 700 hours before failure. The expected life in this failure is due to many factors, but one big factor is load. The expected and the load comes from the hardness of the wood and the moisture of the wood, and the throughput of the pellets through the pellet mill. The expected life of the roast shell is about 1,000 hours. So the general manager, all he wanted to do is at least have the bearings last as long as the roll shell. So we wanted, that was our goal, to reach 1,000 hours for bearing life. And the just the mechanics that were refurbishing the bearings were reporting that using a competitor's lithium complex grease, which exactly meets the specification of CPM, the, bearings were pitted for sure. Okay, so we looked at different wood pellet mill grease candidates for a CPM wood pellet mill. Tried to stay close to their specs, but the different but we also looked at calcium sulfonate greases that we would expect to perform well in the pellet mills. And so if you look at, remember I said this is a high load environment. So you want to look at wear protection data. When you compare the recommended lithium complex grease and the calcium sulfonate grease. Recommended lithium complex grease types, the 4-ball well point, up to 315. The 4-ball well point for calcium sulfonate greases were 400 and 500 kilograms. If you look at our load wear indexes showed a disparity also. The CPM recommended type greases, load wear index of 42 and 50. We got a 73 load wear index and a 50, almost 58 load wear index for the calcium sulfonate grease. If you look at the base oil viscosities, and this is why I say that the most important property of or component of the calcium sulfonate grease is the thickener itself. I really personally, and what I've seen from the people that are smart enough to formulate these greases, you get the best natural wear protection from calcium sulfonate grease if you stay within 100 centistokes base oil viscosity. There are many calcium sulfonate greases out there with up to 460. Here's one here, base oil viscosity. But if you formulate one like that, you lessen the stability of the thickener and base oil. Stability, you lessen the ability of the thickener to hold on to the base oil, and you have to add a whole bunch of additives to compensate for having bigger molecules of base oil versus allowing the calcium sulfonate thickener to do its work. So the better candidates were these two. The 100 with 100 centerstoke base oil and 150 centerstoke base oil. So the winning candidate was the cast and sulfonate complex grease with 100 Centistoke base oil and much better load wear index and 4-ball number and pretty darn good 4-ball scar diameter. Just in comparison, just for kicks. I mean, I just spent a lot of time talking about what CPM requirements are. Andrews is more they allow different types of greases. I guess more liberal um, with their grease specifications. So they'll recommend. This is on their approved list of products. A mineral-based clay grease. Here's a mineral-based lithium complex grease with no solids in it. Here's a mineral-based aluminum complex with grease with solids, graphite and moly. There's a mineral-based calcium sulfonate grease with solids, 460 base oil, and 5% moly. Here's a mineral-based lithium, straight lithium grease with solids, 1500 Centistoke base oil viscosity right here. With graphite, and moly in it. So their grease requirements are really not based on scientific studies or working with one supplier. They just pretty much had suppliers come in and demonstrate the greases, and if the bearings last long enough, then great, it's approved. So that's pretty much the Andrews approach. Well, this case study for high load protection is based on the CPM 7900 series wood pellet mill. And so here are the results. The solution was put them on this cast and sulfonate grease. Here are the results. And also we are able to reduce their greasing rate. Well, that shows here in the cost calculation. Cast and sulfonate grease survived a sustained 308 degrees Fahrenheit service. My next case study will show operating temperatures higher than that. Our calcium sulfonate lubricated bearing has lasted at least as long as each roll shell. As a matter of fact, they're lasting longer. They're still in great shape after 1,000 hours of service. So, as a matter of fact, and another good point to point out is that one of the rolls overheated overnight to 380 degrees Fahrenheit while the calcium sulfonate grease was in service. But it stayed in service, and once that roll was torn down or pulled out of service, it was still rolling out. It was still rolling after cooling, and technician reported that the bearings in service with calcium sulfonate were not damaged and are reusable, even though it reached quite a bit, 380 degrees Fahrenheit overnight. So let me show you how we demonstrated savings ranging from $700,000 to $1 million per year just by using a more expensive calcium sulfonate grease versus the synthetic lithium complex grease. Well, there's 12 presses, 24 bearings, previous failure rate, 2 weeks. And so, well, what if we just, at least allow your bearings to last for a month? Each bearing costs $2,200. Annually, I could save them just on the cost of bearings, $650,000 annually. Well, I suggest that you reduce the amount of grease that you consume. Well, they're feeding these 12 pellet mills with a drum, so we're just using drums as a rate unit, drums per day. So they're using about a drum a day. We could reduce their consumption rate to 0.75 drums per day. Our grease costs more. It's like $13.61 per drum. The synthetic lithium complex grease is $1,200 a day. Per drum, excuse me. It's still expensive, but ours costs more. We're still able to save them $65,000 a year. So a grand net savings is at least $700,000 a year on savings to this operator. And that was a big deal because they're very tight budgets at these wood pellet mills. So let me running out of time, but we'll show you our last case study, which is in a high heat environment at a corrugator plant. And again, the solution was the calcium sulfonate grease. Here we go. We have a cardboard box manufacturing plant. The boxes were used for non-food service, so a NSF H1 grease was not required. There are NSFH1 cast and sulfonate greases. So, but this case study was for non-food service. The corrugator, the equipment is a corrugator and preheater. These are the hottest parts of the cardboard manufacturing process. The equipment is the SNS 87-inch single phases with the BNC fluids model. It's a 1970 model HKE. A new machinery like this costs 12 to 15 million dollars. This is expensive stuff. One just replacing a roll with bearings on each end costs $15,000 just to buy the roll. They were using an expensive polytetrafluorether um, uh, with a thickener, PTFE thickener with a polyfluor poly propylene ester, I believe is what it's called, PFPE base oil that evaporates. The It's the NSF H1 grease. The retail price of this grease is $150 per 14-ounce tube. They could only go 2 weeks before regreasing, so it's a 2 weeks grease purge interval. The operator committed to us to use the cast and sulfonate grease if it performs as well as the current and protect their critical bearings from wear in the high temperature environment in which they operated. So this is an example of high temperature environment, but where do you get the temperature from? High loads also, but this is just a higher temperature than the wood pellet mills. Outside of our grease purging process, these bearings operate in about 350, in excess of 350. I'd say probably average 320. They range from 325 to 375. Just depends on the thickness of the paper that they're processing, the cardboard. So the moisture is a high moisture environment because the paper's still wet, and the rolls are heated with steam. Very extreme pressures, which generates what? The higher temperatures. So the PTFE, PFPE grease was caking in the high temperature bearings. That's why a 2-week grease purge was required. The customers are spending about $3,300 per month for grease used in this corrugator and preheater roll bearings. The PTFE, PFPE grease turned brown and clumped within 2 weeks. So that's their purge interval. I mean, it'll still move, but the clumpiness, what does clumpiness generate? Generates heat. Here's our solution. Use our calcium sulfonate complex grease. It's rated for continuous service up to 390 Fahrenheit. It has the same wear rating as the PTFE, PFPE grease. So, again, this is a high temperature application. So I just really showed this slide and this slide to demonstrate that I actually sat there for a day or two and logged the condition of the grease as we purge. So the process was to pretty much purge. I think I wrote down here. Yeah. Well, purge, let it run for 15 minutes, monitor the appearance of the grease. Was trying to go from a white grease to a red grease or a tan grease to a red grease. So take about 3 purges, 3 cycles of purges, 3 or 4 cycles of purges within that setting that day to totally purge the PTFE grease out and replace it with cast and sulfonate grease. You notice these temperatures are not as high as what I claimed, but these are just temperatures during the purging process. But after I've left, and they would follow the entire grease purge interval of 2 weeks, that's when the temperatures would go up to an average of 350, and which is normal. And so the grease began, say the purge the old grease out, cleaning it, refilling it with cast and sulfonate grease. And this is while the rolls were in operation, while the machinery was in operation. That was the purging process. So it was a very, very thorough purge. 2 weeks later, the customer would fill another roll with the cast and sulfonate grease. So when I went there to demonstrate the purging process, that was just one of the 8 rolls on these corrugators. So every 2 weeks, they would they would purge and fill another set of roll bearings with the cast and sulfonate grease while the machines are operating. This process continued until all the corrugators were full of cast and sulfonate grease. It's about an 8-month trial. The grease purge interval remained at 2 weeks. Um, it is and the calcium sulfonate grease at those temperatures, it'll turn brown, and it turned brown, but it stayed fluid, and that was really impressive to the operators because you have a fluid grease versus a clumpy grease, you're going to have lower operating temperatures by nature. So the mechanics loved the fluid condition of the grease. It stayed fluid. It didn't cake up. The monthly spend, here's the big thing. This is operational savings here, direct savings. Monthly spend on grease had dropped from $3,300 to about $310 for buying the cast and sulfonate grease. It saved them almost $36,000 per year. This reduced their annual spend by more than 90%. So the moral of the story is the use of a cast and sulfonate grease in the right place at the right time can, if you're familiar with Mattress Mac, can save you money. And so that's quite a bit of the excitement that I get from helping customers with cast and sulfonate grease. So I want to thank you for your time and listening, and let's start a discussion here. I totally ignored the chat box, and let's see here. I'm going to go in the chat box and see what questions we have. Let's see here. From AJ. Oh, okay, times, I'm sorry. Okay, from Bashad.
Do you want me
Okay.
to read that or?
Yeah, sure. Read it for me.
Yeah,
And
I read it so everybody can hear that.
okay.
Have you seen any lubrication lines clogged by calcium sulfonate complex grease?
Um, the the lines themselves, I'll say no. The clogging that I've experienced is through filters, strainers. Um, there's uh, I've had an experience where the strainers, whether they're 60 mesh or 100 mesh or 40 mesh, the calcium carbonate uh, would actually get caught by the strainers. And I think it would have to be more of an affinity of the metal, the calcium carbonate to the metal of the strainers. But and that would create a problem with the strainers. It would collapse the strainers. It would build up so much just based on
Mhm.
the massive volume of grease going through them uh, that it would clog the
Okay.
strainers. But as far as the grease hardening and clogging lines, I have not. But it doesn't mean. I mean, I'm not sure how that would happen other than overheating, at temperatures above 400 degrees Fahrenheit. Or if you use a cast and sulfonate grease that's not rated for cold temperature service, then it's not a cold temperature grease. If it's not rated that way.
Okay. Okay.
It,
So thank you very much. The next question is you mentioned that the ISO 100 is the best base oil viscosity for calcium complex sulfonate, if I hear it correct. Uh,
yes, but
so
that's speaking from someone that doesn't have a PhD. But when I listen to the PhDs talk and listen to their presentations, once they get above 100 sentence talks, I see wear protection going down on their test results.
there are some products in the market that they have some like polymer added to the base oil. So the
Okay.
original viscosity is 100, but with the polymer is 300, 400. So will that affect that wear protection in general?
Oh, I see what you're saying. The polymer, the polymers that help stiffen the grease. That's the primary purpose of the polymer. Um, I would say that um, Yes, the polymer by nature, I would imagine that the polymer would help with, uh, could help with wear protection. Um,
So I
but
mean, because that
just
polymer
the
increases the
nature
visual
of,
viscosity.
well, it's using, let me clarify again, the polymers are really there for stiffening the grease. And the if you run a wear test on a polymer by itself, it's not a I don't it's not a great wear protector. You still have to have anti-wear additives. So, but polymer versus a base oil, I would say they rate the same. So I get it, but you get your better wear protection from the thickener versus the polymer. So what I'm saying is it's more effective. We've learned through lubricant science that additives are more effective in wear protection than base oil viscosity. So yes, sure, theoretically you can add to quote the base oil viscosity, but you don't get much benefit from as much benefit from that as using a very good anti-wear protectant.
Okay,
So in this case, the additive is the calcium sulfonate thickener. So if you use
thanks.
a lot of polymers, yes, you can technically make the base oil thicker, but if you look at the effectiveness of wear protection from a thick base oil versus a good anywhere additive, a good anywhere additive wins
Gonna
out
win.
everything.
Okay. Okay, thanks. The next question is it possible to reduce cost of the grease by optimizing the thickener content for the calcium sulfonate grease? Sometimes it is difficult to convince a price-sensitive customer to switch to calcium sulfonate.
Hmm. Well, you're taking away the core of the product if you're reducing the thickener content. Yeah, sulfonate greases are formulated with more thickener than the lithium complex greases typically, but that's what makes it work. So if you take the thickener out, it won't hold on to the base oil as well. It won't give you as good natural wear protection. It won't give you as good corrosion protection. So the more you diminish the thickener, the more you diminish the natural properties
Mhm.
of the calcium sulfonate grease.
Okay, so thank you. The next question is, I understand that the calcium sulfonate is not compatible with other greases. Can you improve upon this, especially for bearings where total removal of the old grease may not be possible?
Well, let me give you a practical point of view on grease compatibility. Uh, as far as can you make them more compatible, I don't know how to do that. But uh, my, you know, there's compatibility differences with different polyureas. There's different polyureas, but let me more practical view of incompatibility. I have not, other than mixing with clay greases, I have not seen incompatibility kick in below 180 degrees Fahrenheit. Typically, it's more like 200 degrees Fahrenheit when incompatibility kicks in. And typically, when the incompatibility kicks in, it's the grease gets thinner and runs out of service. So um, I don't just go by the golden rules on the grease compatibility chart. I like to run compatibility tests, and I've gotten to a point where I'm just so comfortable with just giving that golden rule and moving forward and just addressing the higher temperature applications as they come because when you get above 200 degrees Fahrenheit, uh, all your greases are getting uh, thinner per se. But to answer your question, I don't.
अस्सलाम वालेकुम कैसा रहा आपका दिन
Sorry, let me. Okay, go ahead. Yeah,
Okay, yeah, yeah. I'm not smart enough to tell you how to make the greases more compatible,
okay,
per se compatible. But I just wanted to give you that practical rule of thumb there.
good.
It's not as bad as you think.
So the next question is, I have seen some calcium lithium greases coming onto the market lately as well. What would you say would be the inherent advantages of that style of thickener?
Calcium lithium or the
Calcium lithium.
calcium lithium. Well, it gives you it gives you the mobility of a lithium grease, and it also gives you the water. I don't like to say resistance, but the ability of the grease to perform in a wet environment.
Okay.
That's what I see.
Okay. So the next question is, you said calcium sulfonate greases do not have great low temperature performance. How do the temperatures compare to a lithium complex?
Okay. Um, the industry says that calcium sulfonate greases don't have low temperature performance. The scientists say that calcium sulfonate greases don't have low temperature performance. That's just if you look at thickener versus thickener. Um, as I also said, that you can formulate a good calcium sulfonate grease to give you low temperature performance, and that's through base oil viscosity and and base oil content and probably polymer content also. Um, and so, what is the low temperature mobility difference? Uh, Man, okay, it really depends on how you formulate the lithium complex grease, because uh, it's hard for me to give a typical there, but you can, you know, hmm. Really haven't looked at it because what I normally look at is cold temperature mobility test, and I don't have it at the top of my head. Um, See if I give you a percentage difference. Yeah, I have. I mean, I've seen a broad spectrum. I'm so sorry.
No, I
I've
think there are
seen.
tables out there probably that compares these numbers in general, right?
There's not in, you typically can't see those numbers in the product data sheets.
Mhm.
And it's really dangerous if you use I don't know that there's industry standard tables that tell you that there's, the co-temperature pumpability of a lithium complex versus calcium sulfonate, because it really depends on how you formulate the grease.
Okay. So the next question is, thank you for your sharing information. What is the price of calcium sulfonate complex I-50 Centesto compared to lithium complex? The pricing.
I didn't catch the last clarification of the
Well,
calcium.
yeah, it says calcium sulfonate complex I-50, probably 150 Centesto, probably. I don't know.
Oh,
Yusuf, can you unmute and let us know what exactly did you mean there? If you can hear me, Yusuf. I don't know if he's in the room or not. Yes, he is. But okay, we
oh,
wait for him to unmute and tell us what's the question exactly. Ahmed said some question, but he's not at his desk. So
yeah, but go back to Yusuf's question. We'll just assume it's 150. But what was the question again?
he says, what is price of calcium sulfonate complex I-50? I think he means 150 Centiostoke
Okay,
compared to lithium complex.
okay, yeah.
So the price
Depends on
difference.
Well, the answer is depends on your salesman. Okay.
Okay.
Yeah. If you want to know the cost, man, I haven't been privy to total cost. So yeah,
Okay.
it's yeah, yeah, no, I cannot actually answer that, and it really depends on the salesperson.
Good. Payment says sooner or later, shortage of lithium would lead customer to calcium sulfonate grease. Okay. Ahmad has a question. How do you compare calcium sulfonate with the polyurea based grease?
They're very similar. Um, Very similar. Cannot remember the compatibility as far as chemical compatibility of the other two, but very similar in functionality. They're both gel-like greases. They both hold on to base oil. If you formulate a polyurea grease well and a calcium sulfonate grease, there's no bleeding of the two greases. They're both really good high temperature greases. Polyurea greases by nature have much better oxidation stability than a calcium sulfonate grease. But their polyurea greases need fortification to give you the wear protection that a calcium sulfonate grease. But they both start out with a very advanced position as far as stability and able to hold on to the base oil.
Good. So the next question from Ken is, with calcium sulfonate greases for bearing fatigue life calculation, should you use the base oil viscosity or the grease apparent viscosity?
For piece, oh, oh yeah, yeah, yeah. Oh boy, yeah. Don't use the base oil viscosity, because that assumes that all the base oil wicks out of the thickener and performs like a fluid. That's what the calculation is based on. I haven't seen any new calculations, any new uh, bearing life calculations, or bearing application calculations for calcium sulfonate grease. I haven't been smart enough to modify those calculations. And but to answer your question, it would be more like using the apparent viscosity
Apparent
of
viscosity.
the calcium sulfonate grease, but that's probably not an accurate answer either.
Okay, so Rod wants to know, if does NLGI grade say 1 versus 2 have any bearing on performance other than pumpability?
Pumpability only, and ability to stay in place.
Only pumpability and stay in place. Okay.
Yeah.
For gear type shaft couplings, calcium sulfonate grease usually do not meet the viscosity requirements set by ASTM. Do they still work as well resisting separation?
What were the last three words? Do they work as well as what?
Do they still work as well resisting separation? So because I think during that rotational force, you don't want the base oil and the thickener to
Oh,
separate from each
resisting.
other.
Okay,
Resisting separating.
resistance different. Okay, yeah, yeah. Yeah, I'd feel very comfortable with a calcium sulfonate grease in a geared coupling. I've used them in geared couplings for sure. Um, you want, coupling greases need to be able to flow without separating base oil from thickener for sure. But you also want the grease, at each geared contact point for lubrication. So, to get the flow, you will have to use a higher viscosity base oil for a higher speed flexible coupling per se. But for a geared coupling, I don't see the need for the higher base oil viscosity. So uh, just for the mobility of the grease in a flexible, in a spring coupling, I would probably feel more comfortable with a higher base oil viscosity. But as far as a geared coupling itself, man, I don't see the need for anything less than a GI1 in a geared coupling. Yeah,
Okay.
I'm not speaking on behalf of Falk either. I'm speaking on behalf of my experience with gear couplings.
So the next question, probably you want to look at some data if you want to answer that. But the question is, you mentioned using calcium sulfonate grease instead of PTFE thickened grease. Can
Okay.
calcium sulfonate grease be used instead of DuPont Cryptox GPL high temperature grease, which is a PFPE oil with PTFE thickener? Very specific question.
Yeah, yeah. You have to look at the application. Uh, uh, I mean, it was it was that type of grease, but you really have to look at the application. I mean, if you want to ask if they're compatible, they were rated as marginally compatible. So it was suggested that we purge.
But
When
you should look at the application to be able
yeah, look
to
at the
offer. Okay.
application. Yeah.
The next question is, how is it important about the TBN of calcium sulfonate thickener that we use in grease reliability?
Okay. Um, you know, the yes, they're very alkaline greases, and that helps with a high acid environment. Um, that's just really a side effect. Now I've seen calcium sulfonate greases just uh, run run out of service when when it has too much acid in it. So it just buys you time. It buys you time in a high acid environment.
Okay. So Ahmed asked about calcium sulfonate application in the cold, low temperature of Canada. You mentioned that calcium sulfonate complex is not good for the cold temperature. So what we should do in Canada for that?
Gosh, nobody heard that you can formulate a calcium sulfonate grease for low temperature service. Uh, yeah, you just have to make sure it's ready for cold temperature service. But I mean, if you compare apples to apples, if you formulate a calcium sulfonate grease the way you formulate let's say if you take calcium sulfonate grease with 220 cinnamon base oil and lithium complex with 220 cinnamon base oil, comparable polymers in them, tackifiers. In theory, the calcium sulfonate grease will not have as good cold temperature pumpability. But if you formulate a calcium sulfonate grease right with the right base oil, the right polymer content, uh, right tackifier, uh, you'll have a really good cold temperature pumpability calcium sulfonate grease. So that really boils down to reading the data sheet and quizzing the manufacturer of the grease.
Okay. Okay, so I don't have any other questions. If anybody else has any question, please unmute and ask before we conclude the meeting. Any question? Thanks, Frank, for replying to my question. Okay. So Ahmed, you wanted to have a copy of this recorded webinar. Please type your email address here. I think I have your email address, but I'm not sure. Okay. So any other questions among the
Those are
attendees?
great questions, everybody. Very great questions. I sure do appreciate them. And again, I represent my opinions and my experiences. It's what I'm representing here.
Thank you, Frank. Thank you very much. So I want to thank you on behalf of STLE Toronto section and our executive team. It was a great presentation, created a lot of conversation. We learned a lot. And if there is no question, I leave the last word to you, Frank, and then
Okay.
you go.
Oh, great. Well, thank you all again. And as Coach Prime says, I'm not hard to find.
Okay. So everybody, thank you very much and have a great day. Bye now.